I'm Jason Mather. I look after fire detection systems for Johnson Controls. So all brands of fire detection systems for the Middle East region is what I look after. We're going to talk about innovation. I started in the fire detection industry 36 years ago. Yeah, it's a long time ago. Yes, I don't look old enough. I understand that, but it's the glass. See, this is me. But it's developed a long time. If I think about the systems that I was installing 36 years ago, it's nothing like it is now. There's innovation there straight away. Yeah, and if I could imagine looking 36 years on, I don't think I'll be around at that point, but if I can imagine looking 36 years on where we will be then, it could be unbelievable where we are. One of the key things that we're focusing on at the moment is what's up on the screen there, the power in the palm of your hand. We're using now more and more technology that an engineer has in his pocket. Yeah, the mobile phone. Everyone has one of these things. Yeah. So what we're doing with these now is we're using these a lot more now in remote monitoring that you can see here. So, for example, we're using this now for a maintenance engineer, for example, to be able to remotely monitor what is happening to a fire alarm system on his site. Yeah. So you can see the image on the screen there is showing a number of troubles that he might find on a system. And by having that information with him, it means that he knows that when he arrives at the site, he knows what to expect. He's not having to drive to the site, look at what the problem is, and then go back and then take the right piece of equipment with him. So by having that information on a mobile phone, absolutely helps him keep in touch with with exactly what's happening on their fire detection system. So we can also use this as a tool for installation and testing as well of fire alarm systems now, which for us is a new thing. It's something that we're just about to start bringing in to the industry within the next couple of months. So for configuration and programming, we're now using smartphones to program our fire detection systems, okay? And we're doing that by using QR codes that are printed now on devices, yeah? So you will scan a QR code on the device. You will enter the additional information, so you might enter a point description, a zone description. All of this information goes into the mobile phone. The device is installed, and the configuration that you have on your mobile phone is transferred from the phone into the fire alarm panel. Now, depending on which panel you're using, it will be done via a USB, or it could be done via a programming cable, or we've even got NFC, near field communication. So holding your phone next to the panel will then suck in the information from your phone into the panel. Once that data is transferred into the panel then goes off and addresses all the devices. Okay, so tomorrow, if any of you guys are around, we do have a demonstration of that later on in the afternoon. So if you want to see that actually working, then we can show you on the stand at the back there. The benefit to the installer is that they don't need special programming tools now. I mean, we've had these for many, many years. We don't need those anymore. We can do everything now using a mobile phone. It's faster, it's more efficient. It means that we've got less chances of any double addressing and faults on the system as we're commissioning. So it really does help us. And it also opens up a wealth of opportunities. Now we've got a QR code on the devices. It allows us to do lots of other things. It allows, for example, and we're not doing this yet, but this is innovation, yeah? It allows maybe, I don't know, the engineer has got a detector, he's not entirely sure how to wire that detector. Scan the QR code on the back of the device and it'll open up the installation manual for that device and show him what he needs to do. You could then build this into e-commerce, asset tracking. Yeah, there's lots and lots of things now that we can do by having these QR codes on the device. And the QR code on the device is obviously unique. There is one QR code for every single device that we make. Okay, so this is where the technology is. This is where the technology is going. We're into the realm now of mobile phone addressing and QR codes. So it's a huge step from where I was doing systems 36 years ago. I don't think we had addressable systems at that point. So it's massive, massive, massive step. Then we also look at networking. So when we look at networking, this is bringing all of the panels together into a single system. Now, we've had networking for some time, but what we have now with networking is IP-based style networking, okay? We're able to link panels together using various types of media. So Cat5, Cat6 style cable, if we want to do that. We can use just standard copper cable, which has been used for many, many years, yeah, and to bring the systems together. We can also use single mode and multi-mode fiber. Okay, so if you go with single mode fiber, you can go 20 kilometers between panels. If you use multi-mode fiber, you can go somewhere around 5 kilometers between panels. So a big distances between these panels. When you're using Ethernet and fiber, we've got a transmission rate between those panels of around 100 megabits per second. Now that's really, really fast. It's faster than we actually need. We don't need that to be as fast, but this is what we've developed, a very broad band of data going between those panels. One thing that allows us to do, or it allows the engineer to do, is if he's doing a program, if he's configuring a network system, rather than going to each panel individually and programming each panel individually, that can take a lot of time if you're on a big site. What he can do is program the whole site from a single location. So he can stand in front of panel number 1 and he can program panels number 2, 3, 4, 5, 6, 7, 8. And the data transmission from the laptop computer through to each of those panels is as fast as being stood in front of the panel itself. So it makes a huge, huge difference to the engineers when they're programming these systems. So we've got a huge bandwidth available to us now, which allows us to do that. We're also, we've got advanced diagnostics built into here. So with fiber and with anything, what usually happens is that the guy that's doing the fire alarm system is not the guy that installed the fiber, or not the guy that installed the copper network, or whatever it might be. So we've got advanced diagnostics on inside the panel and on the boards, which will help the engineer on site understand if there's any problems, where that problem might be. Okay, so a big help for the engineer. And at the bottom there, you can see some topologies. Usually we would install a nice ring, yeah, so one panel here and then connect them all together in what we call a Class A circuit, a big ring. That allows, if a cable is cut here, we've still got all the panels working. But not all systems, not all sites lend themselves to be wired in a very nice Class A circuit. So we've got many, many different types of topologies that we can do now, which wasn't available in our previous networking. So again, innovation. This is helping engineers and helping designers to design systems at however suits the project the best. Just an example, many systems have audio built into them as well. Yeah, so the systems that we provide have audio in there as well. When we have audio, so this is speaker systems, voice evacuation, fire telephones. When we have audio, prior to having the network that we have available now, we would have to have a fire network wired between the panel. We would also have to have an audio network wired between the panel, and we would also have to have firefighter telephones wired between the panel. Yeah, so we'd need 3 sets of networking to bring all of this together. The top one shows copper, and the bottom one shows fiber. We're using now a fiber network to link the panels and link the audio. Firefighter telephones over fiber was never available, so we've always had to do it wired using modems inside the panel. Now, it's not the most attractive way of doing it. Yeah, we could do a lot better. So on the networks that we've got now, yeah, we can now do this using a single copper cable, or much preferred is 1 strand of fiber between the panel. And one strand of fiber between the panel will allow you to do your fire networking. It will allow you to do your audio networking, and it also allows you to do your firefighter telephone networking, okay? And as a company, we're also looking into area of refuge as well. So you imagine a firefighter telephone and an area of refuge system is very similar. Essentially, it's an intercom system, okay? So what you'll see in the future is that we'll be building area of refuge into these systems as well, okay? So, and be able to bring all of that together using, if we wanted to, 1 single fiber strand, yeah? And even with all of that data going down, we are using a fraction of the 100 megabits per second that we've got available to us. So great for the future. It's more than a fire alarm network, okay? So with this 100 megabits per second, we're using a fraction of that. We don't need all of that, so why not use it for something else, okay? So we could use that to create, if you have a graphics system monitoring the fire alarm, and you want to have 1 server and maybe a number of clients around the building or around the campus or whatever it might be, we can do that here. And rather than installing it on the client's network, on the client's IP network, we can actually do that now using our resilient fire network, okay? So you've got a network that goes around which is UL listed, it's supervised, it's battery backed, yeah? So we could use that network to also bring all of the client PCs back to a single location. If you wanted to, you could also send CCTV down there. If you've got a camera that you want to bring in and you've not got a network available, hook it onto here and it will take the information all the way through and out to the camera monitoring system. So that could be available as well. So that 100 megabits per second is open to anybody that wants to use it. Connectivity, it was spoken about, and it's on everybody's lips at the moment. Yeah, everybody wants to bring these systems together, okay? It's a small world, yeah, and it is now. I mean, with the technology that we have available to us, yeah, we can very easily now speak to our families, which we couldn't do many, many years ago, yeah? Typical use case is a university campus, yeah? So a university campus is a big area with lots of individual buildings on there. And you've got a maintenance team that are looking after that building. Now, it'd be great if the maintenance team could see the problem before they actually got on the road and got to the site to find out they didn't have the part with them. So now what they can do is look at the information on their mobile phone, they can see what the problem is, make sure they have the right part with them, take that part and then fix it first time. That reduces unnecessary travel. Yeah, it means that we're on the road less. If we can get there and fix it first time, much, much better for everybody and much better for the environment as well, if we're not rolling people on the road constantly. So university campus is one example. Another one would be maybe the banking institutions. A little bit different than university campuses in that they've probably got one building located across a country or a region or even globally. Yeah, so we can bring all of those panels together now and monitor them on a single location. So their ability to be able to monitor banks means that if you've got a maintenance team looking after banks, for example, in maybe Saudi Arabia, yeah, it's a huge area. Rather than driving from one place to the other or finding out you've not got the right part, look at what the problem is before you get there, take the right part with you and fix it first time. So similar kind of thing. And then looking at telecommunications, again, similar to banking, but very small systems, maybe just looking after a mobile tower. But that mobile tower is critical to the infrastructure of the company, of the country. So we put a fire alarm system in here, making sure that this tower is okay, to make sure there's no fires in there. Again, it's exactly the same as the banking. If there's a fire in there, we know about it straight away. If there's a fault in there or a trouble on the system, we know about it straight away, and we can send an engineer to fix that very, very quickly. So that's an example of connectivity and where the whole system is going. Ease of use. Now, we're developed, and not only us, lots of companies are developing now touch screens. Fire alarms are not the most friendly of things. Yeah, I mean, first of all, we make them red. Yeah, and we put lots of LEDs and we put lights on them and buzzers, and they can be a little bit scary. If you're not familiar with how to use a fire alarm system, people just don't like touching them in case you do something wrong. So if you do something wrong, the likelihood is that you could evacuate a whole building, which is the last thing that anybody wants to do. So the more information that we can put on a screen, then the less chances we have of causing a problem, of evacuating a building unnecessarily. So with these touchscreen displays, we can have enhanced language support on there. So whereas, for example, Arabic may have been a challenge for us on our LCD displays, in here, we could do that if we need to. We can put Arabic on here, and we could have multi-language support on there. With more information on the screen, it means there's less chance of any faults, and we also, any mistakes, I'm sorry. And then with color coding on there as well, if we can color the fires as red, and we color the troubles as yellow, and we color the isolates or de-isolates in blue, it means that the security guy on site can very, very easily see what's happening with these systems. So when we look at where we were, this was the display that we had previously, and it's still around, yeah, but many, many people now are opting for the touchscreen display as opposed to the old LCD display. Then looking at safety and reliability, we are here to make sure, my job is to make sure that we get people out of buildings. Yeah, my job is to make sure that we detect the fire as early as we can, and we get people out of the building. The thing you can see on the screen there, the notification device, is the device that's going to get people out of that building. We need to know that that device is working 100% of the time. Now, we do maintenance on systems, but I mean, how easy is it? In this hotel, for example, how easy is it to operate the sounders and go around and check that every single one of them is working? It's almost impossible, because there are notification devices in every single hotel bedroom. Okay, so do we operate all the sounders in the hotel bedrooms? If we do that and we leave it going for maybe 20 minutes, 30 minutes while we go and check them all, they'll all be in the Ratana next door because it's nice and quiet in the Ratana. Yeah, so it's not going to do the Hilton any good. So having self-testing in these devices is extremely important. If we look at automatic self-testing, an engineer can go to a panel now and he can say, I want to test this circuit. So what will happen is the panel will now turn the sounder on for 1 second, it'll flash the device one time, and you'll get a feedback to the panel to say, yes, all those devices are working. Excellent. If you're in a hospital, though, you might not want to do that. If you've got a notification device in an operating theatre, the last thing you want to do is to operate a sounder even for 1 second, just while the surgeon's going in there with a scalpel, because he could do something he's not supposed to. So we can do manual. So these devices have got a read switch in there. So you put the system into manual mode. You say, I want to test these devices. You go with a magnet to the unit, and it will operate the sounder for 1 second, and it will flash the visual device for 1 second, proving that that device is working. If you didn't want to be in front of the panel when you were doing this, you can also do scheduled testing. So it means that at 2 a.m., on every Tuesday morning, you could just do a self-test of the system. And when everyone came into work the following day, you could then look at the panel, and if there was any devices that failed during that overnight test, it would tell you about it, okay? So this is where we are going with notification devices, because these things are very, very important to make sure that we do get people out of those burning buildings. And then just very briefly, because I've had my 5-minute get off the stage. I believe the stage disappears if I stand on here for more than 20 minutes. So detection, innovation, yesterday, today, tomorrow. As an industry, all fire detection manufacturers are working to two goals, and there's a very fine line between those. We're trying to detect fires as early as possible. This is life-saving technology. Yeah, this is what we have to think. This is not just installing a detector and going, it will be fine. We have to put the right technology in there to detect the fire as quickly as possible so that we can get people out safely as early as possible. But on the other side of the coin, we also have to make sure that we've got the technology in there to remove unwanted alarms. Yeah, and you all know it. People get desensitized to fire alarm systems now. If the fire alarm went off in here now, what would you do? Would you immediately go, oh, there's a fire, and leave? Yeah? Or would you just go, oh, it's fine, I'll be okay? You'd be looking at me. If the fire alarm goes off, by the way, I'm out of that door. Yeah, and I'll see you in the car park. We can carry on there. But this is where we are. We're all desensitized now to fire alarm systems. So we've got to make sure that we've got the right technology to reduce unwanted alarms. We've used several methods over the years, multi-sensor technology, the different sensing technology, improving smoke sensing, and then algorithms built into the panels as well to determine if a fire is real or not. We're working right now on our next generation of detection. It's one of my projects that I'm developing at the moment. So you can expect better detection technology. You can expect increased algorithms, better false alarm, unwanted alarm reduction. And detectors now have 365 days a year, 24 hours a day, monitoring inside them. So if any of those elements fail inside the device, then we can let people know that there's a problem. So, and then in flame detection, you will also see advancements as well. Enhanced IR, but also IR array. So being able to identify where in the field of view fires actually are now. So this is it. I've had 20 minutes to talk about fire detection systems, which is really very, very difficult. But I hope that I've managed to just capture a few of those points. We're going to be here for the next couple of days. So if there's anything that you'd like to come and talk to us about, if there's any of those points that I've mentioned on the screen that you think are interesting, that you'd like to talk to us about, then please let us know, and we'd be happy to come and talk to you. Okay, and with that, I'll say thank you.